Welcome, John, and good morning.
Good morning.
Good morning. You're with us from the future, the 7th of December.
I am indeed. Yes, it's 5:45 a.m. Out here in very warm Brisbane. It's I think 27 degrees outside at 5:45 in the morning.
Oh my God.
it's
We have
going to get to,
-5
it's
here.
going oh wow, it's going to get to 34 apparently today. So it's going to be interesting.
Yes. So welcome to Func Prog Sweden, and thanks for waking up very early from the future. And let's
It's
head
my
over
privilege.
your yes, let's head over to your presentation. This is not a Mona tutorial.
Yeah. So well, are we able to see the screen? Am I seeing the screen? No. There we go. Learning anything new, because anyone I spoke to is effectively used terminology and mathematics and different concepts, and every discussion I had basically made me feel like a complete novice. And I'd had 2.5 decades of experience at that time, and I was still not prepared for FP in some sense. So I soldiered on and basically worked in the FE industry for a while. I got the opportunity to basically write a new programming language for quantum computing using functional concepts, basically defining everything in terms of a free monad written in F sharp. And if those words mean nothing to you, that's perfectly fine. All I'm saying is that I've come a fair way, and the biggest learning I've had has been in terms of how to communicate these concepts to other programmers, some of whom may actually not have the foundation, or like myself, not have a clear understanding of some concepts. But mostly, I think we get it wrong when we talk about how we do um, how we do this, because we usually bombard them with a whole bunch of um, new terminology and so on, which really is, I think, a non-productive way of going about it. So I'm going to try and take an approach with a common problem today and try and see if we can work out, what a reasonable solution might be. And then eventually we'll discuss how FP fits into it. And maybe that may be an interesting introduction to some of the advanced concepts to people who aren't necessarily interested in learning all the FP rigor to start with. All right. So I'll introduce myself. My name is John Azariah. I'm a principal engineer at Microsoft. I work on AKS. I have a functional programmer. I'm a functional programmer with a fair bit of experience in programming language design, and I am interested in type systems. And I've been doing this for some time. You can hit me up on email or on Twitter for as long as the website exists. At those handles. We'll come back to this in a bit. Right. So one of the more interesting or less interesting things that I do in my day job is to write Go code, right? And we've all written code like this. Turns out that in Go code, this is like the pattern that you follow. You call a function, check its error value, and then call the next function with values only if the error is not null. And you intersperse this error code all over the place. Perversely, um, this is touted as an example of how Go is easy to program in. I look at it from a type systems perspective and um, kind of laugh, because this is exactly the wrong type to use. They're using a tuple to return value in which both the components of the tuple may be set, but we only check for the error first by convention. What we really need is a choice type in this case, where you either get an error or you get the value. But obviously, this is advanced type theory as far as Go is concerned, and we're all told that this is the best way to do programming, and I actually don't think so. Let's go back and see what the problem with this code is. So first of all, you can see that today somebody has actually gone through a recent code review and so on, and actually made sure that the error checks are there for every function, and you can check every time before you return. But you can quite easily see that this is a convention, not anything else. If sometime in the future, someone may decide to actually not do the error check and slide it past code review, and now you have a runtime configuration issue. So that's a problem. So we want the error check to basically somehow be mandated in this mixture. The other thing is, it's really difficult to figure out what the heck is actually going on, right? What we really want is a condensed version of this code, which doesn't have all of this noise. You want a signal to noise ratio that's better than what you have here. It turns out there's only 6 lines of code in this function, and 12 or 18 lines of extra white space to do this error thing. And then let's meditate on this for a bit, right? Like, part of the problem is when a function, say like the very first function here that says config returns a JB config, once config returns the JB config an error, it doesn't have any control at all about how to mandate the error check. There's no way for config to control how the caller is actually going to use the return value. Right? There's no way to do that. And in some sense, that's what we're asking for, because we're really saying that in order for us to basically write these things out in a nice, safe way, the calling function needs to somehow have the ability to tell the caller, look, behave this way, otherwise, you're not going to be a good citizen, right? And that's a problem. That's the problem we kind of want to solve. So 2 problems. One is we want to make it so that the code is less noisy. The second one is we want to make the error checks mandatory, right? So this is what we just said. So what we need to do to wrest the control back is to basically say, okay, look, let's use, first of all, let's use the correct type. Let's make it a choice type. Let's make it so that you can either have a value or an error, but not both, right? And then, so that let's make that happen. And then make sure that the caller has no choice but complying, right? The caller has to comply with the rules, because the called function is going to return the value in such a way that the caller really can't make a choice. Now, the F# people here will look at the succinct choice type over there, and then they would look at it and say, look, we are going to basically just do error checking like we used to, the same way as Go, right? Pattern match and so on. But we don't want to do that. Let's just step back from that approach and just look at it as error checked is this code. Now it's a class that basically wraps a value or an error and doesn't let you decide which one it is, and doesn't let you actually get a handle to the value, right? So in some sense, when we do that, we have this kind of code that isn't quite working. Like, there's no real way to make this work just yet. But ideally, we've encapsulated the error piece into this error checked thing, so we can comment out those error checks, and we'll end up getting a lot less noise in the code if you ignore the comments. Right? So let's take a look at what we've done. We've made it so that the caller can't cheat the error checker, and we've removed a fair bit of clutter. But obviously, we've left the code completely broken. Nothing's actually happening at this point. We can't even call the next function because the next function doesn't know what to do with this wrapped type. So let's move on and see what we can do next. So next thing we can do, because we're kind of functional programmers, we kind of know the answer is instead of asking the asking the caller of this function to unwrap the value, which is what was happening in the Go code. If you remember, we were trying to figure out whether we had an error or whether we had a value. We unwrapped the result that came back from the called function, right? And then using the called value, instead of doing that, let's actually make that call a responsibility of this wrapping class. So we'll add a method on the wrapping class, which is literally the only way you can get a handle to the internal values. Except that we are going to be super smart, and what we're going to do is we're going to pass in a lambda. So we're not going to give back the value to the caller, right? What we're going to do is we're going to say, I have the value, you tell me what you want done with it, I'll do it for you. And we implement that code. It's actually a very simple piece of code. And in fact, when you do that, it means that this pattern matching thing happens in this helper class. Helper method. You don't have to actually write the wrapper class. You don't have to write the match function everywhere. And that might actually reduce your signal, increase your signal to noise ratio, reduce the clutter in there. And if you do that, then we can force the error checking to get done every time we want to get started, right? So the code looks something like this. Now, when we want to do that, we have to chain the calls somehow. We have code now that doesn't quite work because we only know how to pass a lambda in, but what lambda are you going to pass in this case? So let's take a look at this code here. What's actually going on? Well, we are returning a JB config. Let's ignore the error for a while. Let's say that the internal check is going to take care of it. And it's going to return this config thing into some blind piece of code, which doesn't quite work, right? And you need to pass that into the second line argument. Now, what I've done is I've taken the Go code, which works, and made a kind of pseudo C#-ish code just to simplify it. But this is really all that function is doing, right? And if you take, what we want to do is the value of config, the first line, the value of that function comes back as an opaque object. Now, you don't have access to the object. All you have is this lambda. And now you say, okay, how do I pass how do I pass in a lambda in here that uses the unwrapped JB config internally, right? And the way to do that is to basically turn the rest of the function, starting from the second line onwards, into a lambda, right? And then call that with a given argument. So effectively what happens is you take this config thing, which returns this wrapped value. The wrapped value has a method called call with value on it. And call with value takes a lambda, which then takes the unwrapped value as part of the argument and passes it to the rest of the lambda. Now, of course, if we do this for the entire function, you'll end up with something horrible, right? You'll end up with this huge chain of functions, each of which effectively executes one line, gets some wrapped value back from that one line, and then calls the next line as a lambda so that it unwraps the value and passes that on to the next piece. Now, this is kind of interesting because what we've done here actually has we've basically turned the problem inside out, and we've turned this piece of code very mechanically into that piece of code, right? And it's really a mechanical translation, but we've taken care of enforcing the error check in there, and we've ensured that the composition of these functions works. Now, if you look at this a little carefully, you'll realize that they're all in tail call position, as in this function, call with value, never returns, is the only thing that returns in this entire function. Everything inside it also takes its entire block and returns just that one value. And because of that, we can convert this whole thing into something that uses constant stack space. Now, that doesn't mean much. All it says is we haven't made it worse, because this piece of code also used constant stack space, and this representation also uses the same constant stack space. We haven't made anything worse. All we've done is turned the inversion of control inside out and found a way to pass the internal values to the rest of the function. And therefore, these two pieces of code are actually equivalent. So having done that, what's our scorecard? Well, we've done the error checking. We've removed some clutter. We've passed values on to the next function and so on and so forth. But God, the code is ugly. I mean, seriously, we can't expect somebody to read that call chain and expect that to be reasonable, right? And now this is where it starts getting a little interesting. While we're technically successful, we are not at a point where it's actually useful. So what we need to do is provide some syntactic sugar to this. So let's take a look at this lambda. What this is basically saying is there's a call with value that passes on the next bit to it. What we really want to do is somehow capture this value, jbconfig, and make that available in some context to the rest of this function. Now, this is kind of what we implicitly did in the old days with the semicolons, right? Like we had a semicolon that said jbconfig equals config, and then a semicolon, and then that passed the jbconfig forward. What we're trying to do is now add this context where it's not just blindly call the next function, but also do this call with value piece in the middle. So let's look at this thing, and let's look at how we do it in F#. Now, one interesting thing to realize is that we can always get to this representation with any language that allows us to represent lambdas. But to go from here to the syntactic sugar piece, even if all the languages that we know of are going to be Turing compatible, there's an enormous difference between which language you pick, because the support for allowing you to put syntactic sugar on top of this representation is very much a function of the language. So in F#, that syntactic sugar is called a computation expression. You do that by adding these two methods called bind and return. They're well-known functions. You don't need to add them into the class itself, but you need to add them in this error-checked builder class, and you create an instance of this. And when you do that, then you can write a bit of code that looks very similar to the standard F# code, with the exception of this let bang thing and this error-checked context. So what this tells you is that in this context, please use the error-checked wrapper and call through its call by value between every single invocation in here. And inside that context, you can unwrap the value. So this let bang basically allows you to unwrap the value of what config would have returned, which would have been the opaque value. We unwrap it, take its value out, call it jbconfig, and make it available to the rest of the sequence of instructions, right? And this is just a syntactic sugar transformation. This is syntactical sugar that does this. So we've converted that horrible looking chain into this by just using this feature of the language. Well, what about C#? C# doesn't have computation expressions, but it has another way of actually providing syntactic sugar for those kinds of call chains, and that's called Linq. So Linq is a little bit more complicated because that call by value actually meant two different things. Either you could call an operation that returned an unwrapped value, or an operation that returned a wrapped value, and the operation of those is actually slightly different, right? So if we enhance our error-checked class to do this, you still have no way. First of all, you have only one. You have ways of unambiguously creating either a value or an error, but not both. And there's no way of actually pulling the value out and checking, hey, are you an error or are you a value? So the caller can't do anything with this value except call map or bind on it by passing in an appropriate lambda. And due to the brilliance of people like Eric Meyer and people who built Linq, all you have to do to basically provide some syntactic sugar is to implement this select many method on it. And this extension basically allows us to export the capability of this class into C#. And literally what you need to do for any other context that you want to write is change this link, add another extension method for this link method. That's it, right? And when you do that, you come up with this syntax, which actually works. The only thing ugly about it is that there's no tuple destructuring in Linq, which seems to be a kind of an odd exception that they have at this point. But fundamentally, you could quite cleanly write out the code that represents these sequence of instructions in the context of doing error checking. And C# allows you to do that. So we have a nice, easy way of doing this. So I'm going to make the claim that in both C# and F#, we have met the goal that we wanted to achieve, which is we want to make sure that there's no way to bypass the error checking by either malice or neglect. There's no way to actually you introduce clutter into this, right? The clutter of doing the error checking is completely abstracted and hidden away. We ensure that it's done. We ensure that you can chain the value on to the next function. And the argument is that this code is actually not horrible to read. It's actually quite easy to read. It's a little bit non-typical in terms of it's slightly different from your semicolon separated C#, but it's still clean and it's still unambiguous and scopes work and so on and so forth. Right. So what have we actually done? And this is the piece where I want to actually focus a little bit of time on. I mean, we've kind of like rushed through the mechanism of the mechanics of what we wanted to do, and we've done some refactoring, right? So where does FP fit into all of this stuff? So let's summarize what we want to do in the first place, right? We wanted to basically say we want to consistently error check the result of functions, and we don't want the error checking to compete for attention, right? That's naively what we wanted to actually do. But after like a little bit of thought, a little bit of analysis, a slightly more insightful approach is to actually state the problem this way, which is we have a boilerplate pattern. We want to take that out from the code, and we want to push the boilerplate into some context so that a sequence of code can execute in that context, and boilerplate is taken care of. That's really kind of what we wanted to do, and so we went ahead with this approach. Now, there are many approaches that we might have been able to take, right? So I'm not going to say that this is the only approach we could have taken, but as it turns out, it seems like a very good approach for many reasons, and we can discuss those later, right? Let's talk about what we did was. What we did was we wrapped all the return values so that we didn't allow the caller to take access to the internal value. And because we didn't allow the access to the internal value, the caller doesn't have any idea of what to do with this context wrapped object, except to invert control and pass a lambda into the context to say, hey, run the rest of this code, run this lambda in the context that you have. Now, the lambda itself doesn't know that it's running in any specific context. And that's a very profound observation, because actually it means that you can change context, so you can increase you can enhance the context, so you can even completely replace the context and keep the sequence of the code that you want to execute exactly the same. And the code that you're trying to run will run in the new context. So say, for example, we wanted to add logging to each line of code. Now, you would say, okay, I would have to stand in there and write all the lines of code for logging and so on and so forth. But if we push that into the context, into the boilerplate, the lambda actually doesn't have a clue that it's actually doing anything. The wrapper, on the other hand, knows that a lambda is about to be run. It knows that an argument is coming in. It knows that it's going to be called. So it can log the value. And you can actually introduce one line of code in the boilerplate and push that context, enrich the context all the way for the entire sequence of things. The other reason why this is profound is actually that because it doesn't matter what the context is, if you have no context at all, that's like a normal sequence of instructions. It's just like a standard sequence of instructions, just separated by semicolons. And that's no context being passed around, or a specific kind of global context being passed around, which effectively means that even the semicolon-based representation of a code is actually a chain of continuations. You can look at it the same way, and we'll come to that in a minute, because that's really where the whole FP perspective changes. Anyway, once you perform the inversion of control, you convert your instruction sequence into this chain of continuations, and then you can apply syntactic sugar to flatten that continuation chain into some palatable syntax. Of course, you can only do that if your language allows you to do it, which is why different programmers with different language proficiencies look at the same problem differently. And that's really a very important observation, because if you start with the context of knowing one language and you view code in a particular way, that somewhat impacts how you view the kind of thing that we're doing right now. So for example, with Haskell and Scala, all of these continuation chains, independent of the context, have the same syntactic sugar capability. You can basically lift the context of any continuation chain and make it look the same with Haskell and Scala. And so Haskell and Scala people will look at this talk and say, what a boring talk. He hasn't done anything interesting. He hasn't talked about any of the hardcore mathematical concepts behind any of this stuff, or even talked about why this works, and he hasn't used the C word yet, and so on. And this is bread and butter. This is our normal way of looking at it. What's the big deal, right? F# has different syntax wrapper for each context, but the syntax inside the wrapper is going to be universally the same. So you always use let bang when you want to unwrap a contextual value. You always use return when you want to take an unwrapped value and put it inside a context and send it out, right? And it becomes part of the idiomatic usage of the language, and all F# programmers, after a small bit of familiarity with the language, will know how to use a computation expression like sequence or async or whatever it is. And its uniform syntax for each context is just that the name of the wrapper around the context that changes. So they're looking a little bit smugly at this, saying, hey, this is like how we do our stuff. We're actually, there's no difference between seek and async. All you have to do is change that, and then your let banks just work, and so on and so forth. And their approach for looking at this is, again, going to be from that viewpoint. C# people will fall in two broad categories. There'll be a small group that's familiar with Linq, and they'll be familiar with how to use it. They're like, okay, I see. So if I use the contextual extension method, then I can just use Linq syntax, and that does all of the unwrapping and the wrapping and in the injecting of the syntax or injecting of the boilerplate into the code and so on, and everything is fine and dandy. But the vast majority, I would wager, given the experience that I have of working with C# programmers, they would look at Linq and say, look, that's sort of hurts my head. I don't need any of this. It's kind of like a scientific curiosity, Yeah, some people might need it, but really it's not very, very useful for my everyday life. And that is really the tipping point, in my opinion. Like, they have the ability to realize that something can be done, maybe don't necessarily use it. C# also makes it more difficult because for different contexts, certain well-known contexts, they have different syntax completely for this desugaring. So, for example, you have the Elvis operators and to the next function if the value is not null. They also have a completely different, completely inconsistent syntax for async. So we write async and then await. And what await does, it exactly does the same thing. Await does the unwrap of a function that is run inside the context of an asynchronous thing. And so people who look at Linq, double question marks, or the Elvis operator, and async, begin to think of them as three different types of things. And that is the perspective with which the language has kind of led them into that point of view. And you can't really blame them, or it's not a reflection on anything other than their background that allows them to look at that perspective. And so informing them about how any of this stuff matters or why is all of this interesting involves looking at it from their perspective and then coming at the problem from there. So in some sense, that's kind of what we did today. We took a fairly common problem. It's pervasive all over the place. Oh, and by the way, Go has no way to apply syntactic sugar. So the only thing you can do is do the call, the continuation chain, which obviously is not palatable. And now Go programmer will look at this and say, why the hell would I want to do that? The best way you can always do stuff is to put the if error not equals null check everywhere. That's the best way to do it. That's the best way to do error checking all over the place. And again, you can't really blame them for having that perspective because their language doesn't allow them to give that syntactic sugar in there. And so the idea that having syntactic sugar allows you to do something much more powerful doesn't have any relevance at all to their point of view. So they look at this spectrum. It's called the Blub paradox in a paper that was written a long time ago. If you look up the spectrum and you say, why the hell would I need that feature? I can do everything I need from here on down. that's not a function of their intelligence or their capability or anything of the sort. It's just a function of the context that they have and the familiarity they have with the language, the affordance of the language that they have, which allows them to basically not necessarily see the benefit of something that is more abstract. And that's really what the conversation is we're looking at this blob paradox. Everyone's comfortable where they are. Everyone has a perspective of why something matters and how I can do something. And it's a hard slog to pull someone one level up, because fundamentally there is no perceptive need for that. Go programmers are happy to sit and write if not equal nil every day of their lives, morning to night, trying to tell them that you can make your code a lot less cluttered and force you to always do the if check automatically has limited value, because they cannot see that within the construct of where they are. But with some other languages, it's worth the slog to go back up. Now, the key perspective from an FP perspective is that all these three blocks are actually the same thing. They're actually the same thing. It's a completely mechanical process to go from the first block of code into the second representation. Because really what you're doing is you are saying, hey, config will return some value. In the null context, call with value simply calls the lambda that you pass with no value at all. And that's really what that semicolon really looks like. If you remove the semicolon and replace it with call with value, and you take the argument and pass it down, you'll get exactly this. And if in the null context, call with value simply just takes the value and passes it on to the lambda. So there's a completely mechanical way of going from here to here. And there is a completely mechanical way of going from here to here using whatever sugaring construct is available. Now, if call with value was just the identity, as in just pass the value along, then this extension method, once you write it for that null context, this code and this code would do exactly the same thing. But if you enrich call with value to do something else, then all of a sudden, this code will have exactly the same structure as this code, but with all of the boilerplate that you want to get executed injected and streamlined into the process of this. And when you look at it from an FP perspective, what have we actually done here? We have talked about representing code as a lambda. That's the functional piece. And then composing these lambdas together in the context of a concept, within a context. So you composed, and this is the first time using that word, you've turned this problem into a composition problem where the composition is composing in the context. In this particular case, the context is the error checked context, which does an error check for every single value. And you've turned that composition into a nicely sugared format. And it turns out that this context is effectively just composition. This is all we're doing is this composition. It's composition within context. We spent a fair bit of time to get here, but that's all we've done is just do composition, function composition within a context. And that's why this isn't a monad tutorial. Thank you.
Thank you very much, John. Very, very, very interesting presentation. Thank you very
Thank you
much.
very much.
Yes, let's see. Let's head over to see if there's no questions so far. How come you got into this kind of functional programming?
So I got into I was a C# programmer from the time C#, well, actually from before C# became C#.
Mm.
I was programming in .NET. I was part of Microsoft in the days before .NET, and I was one of the people that worked on a little known language called J#, which was effectively Java on the .NET CLR. It was an abandoned project after we shipped version 1, but that was one of the first. So I was basically working on .NET for a long time. I learned a little bit of FP in college, but obviously, there was no real functional use of it in industry until much later, when JavaScript came out and we started writing web applications. And I was introduced to 2 or 3 seminal papers on using continuations and that kind of thing in JavaScript. And then from there on, I had an interest in programming language design and code generation. So functional programming became very much a foundation of that, because you're transforming code, and when you do that, you're really transforming functions. So you're trying to find ways to actually represent functions and then transform them and so on and so forth. And eventually I landed up getting the opportunity to work in Scala. And I got a deep dive into the whole applicators and functors and monads and all of the other stuff that, the big terminology and everything. And it was a fascinating time, because for a year I was probably one of the oldest people on the team, but one of the most junior in terms of understanding any of these concepts. And I kept learning a lot of stuff, which turned out to be very useful. So when I landed up working in Microsoft and getting involved in the quantum programming team, we landed up having to find ways to encode instructions to go down to the quantum computer. And I looked at it and I'm like, hey, that looks like a language to me, And so we eventually implemented a pseudocode of that language using a free monad, and we had to write the free monad interpreter. And because there could be tens of thousands of instructions, you run out of stack space. So we landed up implementing a trampoline. And all of these heavy lifting pieces came from the FP experience that I had. But in the process of doing all the heavy lifting, I was working with a whole bunch of really smart people who had no idea what the hell I was talking about when I used any of the terms. And so the joke is that every time you have a conversation with John, you'll bring monads into the conversation. And what the hell is a monad? And so I tried many times to have a gentle introduction to monads, failed miserably. I think at the end of it, coming at the problem from the perspective of somebody who has coding problem they can relate to, and then introducing them to the pattern without necessarily bringing in the category theory, I'm hoping that actually works out as a better, gentler introduction to the concept. And that should trigger some aha moments like, hey, those 3 things are actually the same thing. Or, hey, what if I have a different context? Or are there any other patterns that look like this? Now, this pattern is about composition and context. What are the other patterns out there? And those are questions that come out of curiosity. And then we can talk about the terminology, and then we can introduce them to the foundations of why the stuff works. Why is it rigorous? Why is it better than anything else out there? And that conversation comes later, not at the beginning, which I think is the mistake that we all make. There is a famous blog post out there called, don't write another monad tutorial or something, which effectively talks about exactly the same thing. Somebody who's understood monads has this aha moment and wants to communicate everything at the same time to somebody. who has not come across on that journey yet. So there's a whole bunch of implicit knowledge that you have accumulated for the bit to flip at some point. And you're talking to an audience that may not have had that flipped bit because they can't relate to the problem you're trying to solve. And I'm hoping that this talk actually moves in that direction.
Yes, it certainly did. Thank you very much again, John. Thank you.
Thank you. Take
Thank
care.
you. And with that, folks, we are done for tonight for the last Func Prog Sweden this year. Then we will be back again in January. We will hopefully be able to live stream also from Vietnam and Ho Chi Minh City. And then we're back here in Sweden on the 17th of January, and then we'll do one meetup per month in next year, as we have done this year. So with that, have a nice December, a Merry Christmas, Happy New Year, and see you next year. Bye.